Okay, guys, good morning. We're going to continue to work on fractions, and specifically we'll look at the least common multiple with prime factorization. I'm going to wait another minute. Looks like I got a little bit early to see if anyone else is going to join us. Okay, you guys, I'm going to go ahead and get started. So we're working with fractions right now, and we're going to add and subtract them with unlike denominators. So for example, if we have 20, okay, my pen wasn't working. Okay, so if we have 22 and 24, and let's just say there's like I don't know, a 5 and a 3, and we're trying to add these. Okay, what we're going to need to do is, and I showed you this yesterday, we have to find a number that both 22 and 24 go into. Okay, so what we're going to do is we're going to break these down using prime factors. So let's start with 22. So if we break 22 down, it's going to be, we're going to have 11 times 2. Both those are prime numbers. Then we're going to have 24. And then for 24, we'd have 6 and 4. Neither one of those are prime numbers, but we can keep going. And then we're going to have, for 6, it's 2 times 3, and 4 is 2 times 2. So what we need to know now is we have 11 times 2. Okay. And over here we have 2, 3 2s, and a 3. So what we need, if we know for 24, we're going to need 3 2s. So there's 1, there's 2, there's 3. So we're going to have 2 times 2 times 2. Okay, what else do we need? Well, this 2 we already have. We have 3 of them, so we don't need a fourth one. But we do need a 3. This one right here is times 3. And then we need this 11. So what we do is 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Then 24 times 11, it's 264. So these are big numbers. That's why when we sometimes prime factorization, it might be a little bit quicker for you. So if we went back up here, we know both these are now going to be over 264. And 5 is going to be over 264. And then we'd add, and we get 8 over 264. Okay. And the other way I showed you guys, which is going to probably be a little time consuming, would be we would factor out all these all the way. So you'd have to do, I'm going to try to make this a little bit smaller. We would do 22, 44, 66, 88, do 110, 132, so forth, because you'd have a long line of numbers going all the way over. Sometimes that's what I'm saying, when you have those big numbers, prime factorization makes it a little bit easier. But let's do another one, just so you get the hang of it. Okay, so let's do one with not so quite big numbers, just so you get the hang of it though. Okay, let's say we have 25 and 15. And we'll say, I don't know, 2 25ths minus, we'll say 7 15ths. Okay, so we're going to do prime factorization. This one's going to be a little bit easier, you guys, because we know 25 is 5 times 5. Those are both prime numbers, okay? And then over here, we're going to do 5 times 3. Oops, let me make that a 5. 5 times 3. Okay. So we know what we're going to need here. Okay. We're going to need 2 5s and a 3. So we're going to basically at the bottom do 5, because there's 1. There's 2. We only need 2 of them. So this one we're going to cross out. So we have 5 times 5 times 3. So what does that equal? Let me get rid of this down here. So 5 times 5 times 3 is 25. 25 times 3, and that's going to be 75. Okay. So we know that 75 now is going to be our common denominator. So if we did 25 times 3 to get 75, we have to multiply this times 3. That's going to be 6. And 15 times 5 is 75, and that's going to be 5 times 7. It's going to be 35. And we'll make this an addition problem just for, so then it's going to be 41 over 75. Okay. But there's another way, you guys, if you want to do it. This one is a little more manageable, and we'll show you the opposite, or not the opposite way, but another way you could do it. We could do 25, 50, 75. Then when the 15s, you could do 15, 30, 45, 60, and 75. And then we get to 75 that way. So I just want to give you 2 ways to do it. But when you get the bigger numbers, you guys, sometimes the prime factorization is going to make it a little bit easier. And we can do another one here just to get the practice. What we will do, let's use, we'll do a 20 and an 8, which it's a little bit bigger, but let's do 4 20s plus 7 8s. Okay, so 20 is going to be 2 times 10. And then we break this 10 down, it's going to be 2 times 5. So at the bottom, we're going to have 2 times 2 times 5. And for the 8, we're going to have 4 times 2 then we break this 4 down, so it's 2 times 2 times 2. Okay. So over here we have 2 2's, and over here we have 3 2's. So we know we need 3 2's. So we'll take the 2 times 2. Oops, excuse me. That 2 times 2 times 2. That's 3 2's. And what else do we need? Well, there's 3 2's. So 2 times 2 is 4. Times 2 is 8. The one last thing we're missing, though, is this 5 times 5. And that's going to give us 40. So 40 is going to be our common denominator. It's the least common multiple. So if we did these would now be over 40. And 20 times 2 equals 40. So that's going to give us 8 up here. And 8 times 5 is 40. So we do 7 times 5, and that's going to be 35. So we have 8 plus 35. It's going to be 43 over 40. Okay. So, you guys, there's a couple different ways you can do it. And really, it's how you feel most comfortable. Okay. For the smaller numbers, you can probably just go out and do the factors. For this one, like for example, let me get rid of all this and show you. This one maybe isn't so time consuming because 8 and 20 are smaller numbers. They're not big numbers. So you could certainly, if you wanted to, do and this is 8. Oops. So you could do the 20, 40, 60, 80, and we'll take it out to 100. And then you could do 8, 16, 24, 32, 40, and you realize, okay, 40 is the least common multiple because I see it in both these, there and there. So there's a couple different options you guys can use when, we have an unlike denominator. The prime factorization is probably the quickest, and it's going to be the most practical when you get those bigger numbers. Like the first one I showed you, when you have like a 24 and a 22, anything in the 20s or 30s, if you're doing this method, it's going to take you a while, and you might have a long string of numbers, okay? So prime factorization, it's probably the most effective way to do it. It gets you the answer the quickest, but certainly you want to do one that you're comfortable with. That's why I showed you both these. So you can kind of do it either way. And, when you're doing some of these problems, I think you might want to practice doing the prime factorization and then just listening to factors so you're comfortable with both methods. So that's really all I have for today, you guys. I will go ahead and I'm going to post some subtraction problems today. But remember, you guys, when you're doing either addition or subtraction, it's the exact same. You have to find a common denominator and then just go ahead and subtract the top numbers, okay? All right, guys, we will see you tomorrow. Have a wonderful day. Bye.